going to balance some chemical equations. Key thing, and I'm going to pull it up, you got to have your periodic table handy. It's a good idea to definitely have scrap paper because you can't do this in your head, and you need to practice this. After I show you these questions, you should do these exact 3 questions again on your own. So that's my suggestion. Let's begin. I'm going to share my screen here. Minimize. There we go. You can see the periodic table. Again, you want to make sure that you know that hydrogen is H2, nitrogen, N2, oxygen, O2, all of group 17 are diatomic, F2, Cl2, etc. All right. Oh yeah, phosphorus P4, sulfur S8. State of matter is all there on the periodic table. Okay, we've got 3 examples we'll look at. Let's zoom in on this first one. What you're going to want to do is write this word equation out with me. I've got it written. I'm going to read it. So magnesium metal reacts with liquid bromine to produce magnesium bromide. This is a formation reaction. What you're going to need to do, look on your periodic table and get the right way to write the symbol formula for magnesium. Well, it's a metal, so it's pretty straightforward. It's going to be monatomic. Bromine, was just mentioning how to write that one. And then here's our product, definitely an ionic compound, right? So it's going to obviously be a solid magnesium bromide. Let's take a look at what we're going to need. Here they are right here, magnesium and bromine. Find those 2 on your periodic table, but this is going to help us out. So you're looking at those on your periodic table. Again, make sure you have your periodic table. All metals are the same. They're all monatomic. Always leave, oops, let's get the right color here. Always leave a space there to balance. We are going to balance these. Okay, MgS, magnesium, solid magnesium. You know that because it's a metal. It's not Mg2 or Mg20, it's just Mg. Reacts with liquid bromine. Bromine's group 17, they're all diatomic. Br2, well, it's also darkly colored here on our periodic table, so it's a liquid. So we know its state of matter. It's going to make this compound here, magnesium bromide. We know it's a solid. Let's get the right formula. Let's do some rough work. So make sure this looks nice and neat. The rough work off on the side, Mg, 2+, bromine, the charge on bromine, -1, means it can accept 1 electron. Magnesium's got 2 to give away. You need 2 bromines, right? It just makes sense. If you got 2 electrons, this one only takes 1. We're going to need to invite 2 to the party. So it's a 1-to-2 ratio. So it's going to be Mg, Br, 2. Of course, it forms a solid. Let's do some balancing. Interesting. 2 bromines, 2 bromines. 1 magnesium, 1 magnesium. This is a 1-to-1-to-1 ratio. Those are the coefficients we put in. 1 mole of magnesium. Hey, we even know how much that weighs. 24 grams, 24.31 grams, plus 1 mole of Br2. So it'd be 2 times that 79 or 2 times 80 approximately to round it. You don't round it, but just kind of doing it in my head. Will give us 1 mole of this compound called magnesium bromide. Nicely balanced. That was pretty easy, but definitely check it a couple times. I would come back to this even after writing it just to make sure it's correct. I'm going to go to the next one. Of course, you pause this video as I'm working through it so you can be working kind of with me as opposed to just sort of watching. You want to be writing everything I'm writing. So you're going to need to use pause. I'm going to do another one. Again, write this down. Aqueous thallium. And yeah, you're going to want to pause the video, obviously. Aqueous thallium-1 hydroxide reacts with aqueous magnesium nitride to produce, you know, the arrow, to produce solid magnesium hydroxide and solid thallium nitride. Wow, so cool. Lots of cool stuff. Find these on your periodic table after you write the word equation down. Again, you're going to want to pause the video so you can write all that down. I'm going to pull it over, though. Here's all the key stuff you got to find on your periodic table for this. Thallium, the hydroxide, the magnesium, the nitrogen, which of course is nitride when we change its name because it's ionic. Let's do some rough work. I'm going to just do it down here so I can get the right formula here for aqueous thallium-1 hydroxide. So it's T, that's an L, right? Anyway, T in a line. That's +1, thallium 1, hydroxide, OH negative 1. Hey, that's good. That's just a 1-to-1 ratio. And what about this magnesium? Hey, we were just talking with this character last time, magnesium, and it's with nitride, right? Magnesium nitride, so N -3. Okay, we're going to need to do a little work here. Find the lowest common multiple between 2 and 3. Well, that's 6. So we're going to need 3 of those, right? To 2 of those. If you think about it, 3 times 2, +6. 2 times -3, -6. That nicely balances out. We're going to have a nice balanced formula. Let's start with those two. Don't need to do the whole thing here on the top of my hat. So it's going to be TL, OH, AQ, aqueous, going to react with Mg3, magnesium nitride, N2, aqueous. Going to go over here, and we're going to produce magnesium hydroxide. Okay, going to have to do that. Maybe I'll do that work right here. Mg hydroxide. This is, by the way, a double replacement reaction. I can see that. MgOH negative, Mg is +2, OH is -1. It's going to be 1 to 2. Okay, so that's going to be Mg bracket hydroxide, but I need 2 of them. And I guess, yeah, forms solid. Okay, super cool. And this stuff, thallium nitride, so thallium and nitrogen. Okay, ultimately these two swap partners, right? The thallium was with hydroxide. Well, now magnesium's with hydroxide. Magnesium was with nitrogen. Now thallium's with nitrogen. And if we're going to combine thallium, 1, so +1, and nitrogen, -3, well, that's pretty straightforward. I'm going to need 3 of these to every one of those. So it's going to be the TL3N, yeah, just N, solid. Okay, got a little bit of balancing to do. I think I'm going to start with the hydroxide. That just, ooh, but then there's a 3 here in the magnesium. Yeah, I could try that. Let's do it as a process, and if I'm not right, I just cross it out. So I'm going to go ... 3. So I got 3 magnesiums. That's good. 3 times 2, so I'd have 6 of those. So I'd have to put a 6 here. Again, I'm not fully sure it's going to work, but that's how balancing works, right? And again, that's the hydroxide I've matched, right? 3 times 2, there's going to be 6 hydroxides going on here because there's 2 and 1, and if we got 3 of these moles, we're going to have, again, 3 times 2. All right, so to get the thallium correct, put a 2 here, okay, because I got 6 of them. 2 times 3. Ooh, look at this. 2 times N, 2 N's. I think we got it. I'm just going to tally everything up here. 6 thalliums, 6 hydroxides, 3 magnesiums, 2 nitrogens, 3 magnesiums, 3 times 2 hydroxides, so therefore 6, oh yeah, 6 hydroxides. 2 times 3, so 6 thalliums, and 2 nitrogens. It's looking good. It's all good. I'm going to outline it. 6 moles of thallium hydroxide, 1 mole of magnesium nitride will produce 3 moles of magnesium hydroxide and 2 moles of thallium nitride. Super, super cool. Love this stuff, right? Again, you're going to want to pause, do it on your own, try it on your own. You saw the process, but you need to do this as well. Do it 10, 20 minutes after this video as well to practice it. One more practice together. Write these words out. Fluorine gas reacts with aqueous lead 4 iodine to produce, right? There's the chemical reactions arrow, produce aqueous lead 4 fluoride and solid iodine. Oh, looks like some things are kind of replacing. Basically, the fluorine's going to kind of kick out the iodine, it looks like, because those are two nonmetals. They can kind of swap places. Let me grab fluorine, iodine. Again, you find these on your periodic table. I'm just pulling them in so you know what to look for, but by now you know what to look for. I'm going to do a little rough work so we can get the right formulas. Well, we know fluorine gas. That's pretty simple, right? Group 17, F2, gas. This is the one we got to make sure I get right. Going to combine that with lead 4 iodine, but yeah, let's do the F2. That's not a problem. F2 gas reacts with, and as you write that plus, literally say reacts with. Okay, do some rough work. Again, get this. You really should be totally off page here, somewhere else. So I'm kind of doing some rough work on the side. Pb plus 4, because it's lead 4, and iodine, -1. We're going to need 4 iodines, 1 to 4. So it's going to be Pb, I4, aqueous, AQ, dissolved in water, to produce. Okay, now the lead is going to link up with the fluorine. Hey, I think it's going to be the same, but let's do the process anyway, right? That was lead and iodine. What if I've got lead and I want to combine it with fluorine? Well, again, looks like it's the same story here. We're going to just want to make this look a little neater. It's looking awful. Looks awful. I can barely read it. All right. Okay, Grandpa. There we go. And that's so much better. Okay, well, 1 lead, and you'd need 4 of these, right? To nicely balance it out, to make a nice balanced ionic compound to produce aqueous lead 4. So Pb and then F4 aqueous and solid iodine. Iodine's also the same group, right? Group 17. You know it's a solid, but it's I2, right? Got to know that. It's got to be comfy cozy how I figured that out. Always group 17 or always diatomic. It's what they need to do to stabilize. Oh, there's suddenly the periodic table. Sorry. Okay, let's finally balance this. Again, you should pause right now and just see if you can balance it on your own. But I'm going to look here, could balance the iodines or the fluorine. Might not matter, might make it harder starting with 1, but I'm just going to kind of, I think I want to do the fluorine because it's kind of wrapped up here with the lead. So if I put 2 here, right, because there's 4 of them. Yeah, so put a 2, just kind of outline it like that. Okay, I got 4 fluorines. That's pretty good. What about the iodine? Oh yeah, I just put 2 here. Okay, I'll get 2 iodines. I think we're good. I think we go 2, 1, 2, 1, 1, 2. Let's just double check. This, no, it's not 2, silly goose. 2 times 2, so it's going to be 4 fluorines here, 1 lead, and 4 iodines. Over here, 4 fluorines, 1 lead, and 2 times 4, 4 iodines. Hey, it's good. It's nicely balanced. So it is indeed 2, and you do have to put a 1 here. You're going to ask, do I have to put a 1? The answer is yes. And 1 mole, because it says something, right? It says 1 mole. We have to look that up. We have to calculate, what would 2 moles of F2 gas weigh? Well, 1 atom of fluorine was 19, right? Looking at my periodic table, yeah, it was 19 grams for 1 mole, but that isn't just 1 atom of fluorine, it's actually 2 of them, right? Right there, and then in fact it's 4 in total, right? 2 times 2. Anyway, we're not calculating the mass just right now. I just want to kind of point that out. You can definitely try that or ask me in class what that would be or confirm it with me. So for your assignment, You've got 6 reactions. You need to write them so they look nice and neat. So basically none of this funny business underneath here. You can do that off to the side and make it look nice and neat like that. And yeah, hand that assignment in. You've got the week if you need to work on it, but I would seriously get it done just in an evening. Maybe check it out, check it the next night, and then you're good to go. Okay, take care. Science 10 signing off. Talk to you later.